March 28, 2025, Thailand is shaken by one of its most powerful earthquakes in decades. A 7.7 magnitude tremor strikes near Myanmar, but its impact reaches deep into Bangkok. In mere seconds, a 30-story skyscraper under construction crumbles. A cloud of dust fills the streets, and people run for safety. Yet, just blocks away, other high-rises remain standing, untouched. How can two buildings in the same city face the same earthquake, but with such? The answer lies in design, materials, foundation, and engineering techniques. Some buildings are built to flex, absorb shocks, and resist collapse. Others? They crumble under pressure, often due to poor construction, weak materials, or outdated designs. This isn't just a Thailand problem, it's a global issue. Around the world, cities and seismic zones battle the same question. What makes some buildings earthquake-proof while others become deadly traps? In this video, we'll uncover the secrets behind earthquake-resistant structures, the biggest mistakes in modern construction, and what we can learn from past disasters. Let's dive in. Beneath our feet, the earth is constantly shifting. Massive slabs of rock, tectonic plates, are in a never-ending push and pull. Sometimes they slide past each other peacefully, but other times stress builds up until the rock suddenly snaps. This violent release of energy is an earthquake. The point where the plates break is called the focus, deep underground. The point directly above it, on the surface, is the epicenter, where the destruction begins. On March 28, 2025, Thailand felt the force of nature as a 7.7 magnitude earthquake struck near Myanmar. The shaking spread through the ground, reaching Bangkok in seconds. Seismic waves ripple through the earth in different ways. P waves move fast, causing sudden jolts. S waves shake buildings violently from side to side. Surface waves roll like ocean waves, tearing roads apart and toppling structures. Some buildings absorb the shock, while others couldn't withstand the force. But why? The answer lies in engineering and design, which we'll explore next. When the ground shakes, buildings don't just go up and down. They sway, twist, and sometimes crumble. Earthquakes unleash powerful lateral forces, pushing structures side to side with immense energy. Rigid buildings, especially those with weak foundations or poor construction, can't handle this force. Instead of bending, they snap, crack, and collapse, just like we saw in Bangkok. But height also plays a role. Every building has a natural frequency, a rhythm at which it vibrates. When seismic waves match this frequency, the building resonates, amplifying the shaking. Certain heights are more vulnerable than others. If the wrong combination of frequency and shaking occurs, even a well-built structure can fail. Some buildings in Thailand stood firm. They were designed to absorb energy with flexible materials and advanced engineering. Others, however, weren't so lucky. So, what separates survival from disaster? The answer lies in seismic design and construction techniques, which we'll explore next. In the blink of an eye, thousands of tons of concrete and steel come crashing down. But why? When a building fails during an earthquake, there's usually more than one reason. In many cases, the problem begins long before the ground starts shaking. Some buildings cut corners during construction, using low-quality concrete, weak joints, or inadequate reinforcements. A structure is only as strong as the materials holding it together. But what's beneath the building also matters. In Bangkok, much of the city is built on soft clay, which amplifies shaking. Without deep, reinforced foundations, structures can sink, tilt, or collapse. Another critical factor: flexibility. Rigid buildings resist movement until they can't. In contrast, earthquake-resistant structures bend and absorb the shock. Many older buildings lack seismic design. They weren't built for quakes. And when disaster strikes, they pay the price. Bangkok's 30-story collapse is a tragic example. Was it a design failure, weak materials, or a foundation issue? Investigations continue, but one thing is clear: earthquakes don't kill people. Bad buildings do. Not all buildings collapse when the earth shakes. Some are designed to move with a quake, not against it. At the heart of earthquake-resistant design are shock absorbers and dampers, specialized systems that absorb and reduce vibrations, keeping structures stable. Strong materials also play a role. Skyscrapers built with reinforced concrete and steel frames can withstand extreme forces without crumbling. Unlike brittle structures, they can bend without breaking. One of the most powerful earthquake defenses? Base isolation technology. In cities like Tokyo, entire buildings are placed on giant rubber and lead bearings, which absorb the shock before it reaches the structure. But modern engineering goes even further. Tuned mass dampers, massive counterweights inside skyscrapers, shift in the opposite direction of seismic waves, reducing swaying. Floating foundations prevent buildings from sinking into unstable ground. These innovations make the difference between survival and disaster. So, can future cities learn from these designs? Up next, lessons and solutions. The difference between devastation and survival isn't luck, it's preparation. Countries like Japan and the US have spent decades engineering buildings that can withstand powerful earthquakes. Their secret? Strict building codes, cutting-edge technology, and a commitment to safety. For mega projects in earthquake-prone areas, the solution is clear. Flexible designs that move with seismic waves. Stronger materials that resist cracking and failure. Smart engineering innovations like base isolation and dampers. In Tokyo, skyscrapers rest on giant shock absorbers, while in San Francisco, new towers are built with deep underground reinforcements. These measures aren't just expensive add-ons, they save lives. Cut to a government official inspecting a construction site. But no matter how advanced a building is, weak enforcement of building codes can lead to disaster. Thailand, and countries like it, must strengthen regulations to prevent poor construction practices. Final montage. Engineers working on earthquake-proof buildings, overlaid with text. The future of safe cities. The next big earthquake isn't a question of if, but when. The real question is, will we be ready? Earthquakes are unpredictable, but destruction doesn't have to be. We've seen why buildings collapse and why some survive. The truth is simple. With better materials, smarter engineering, and strict regulations, disasters can be prevented. The question now is, are we willing to invest in safety before the next big quake? Governments, developers, and engineers must make earthquake-resistant buildings a priority. But change doesn't happen without public demand. What's your take? Should governments spend more on the seismic safety? Or is it too costly? Let us know in the comments below. And if you found this video informative, make sure to hit the like button and subscribe for more deep dives into engineering, disasters, and the future of construction. Because the next earthquake is coming, and only prepared cities will stand tall.